And I always have to think about how I want to word this. I think I'm going to do it this way. We are going to be allowed to change a row, I guess any row. We can change a row by adding a non-zero multiple of any other row to it. Okay. So we're allowed to pick a row and then change it by adding a non-zero multiple of any other row to it. Okay. So what does that really mean? What does it mean to add a row to another row, or by add a multiple of a row to it? So let me just sort of show by example real quick what this kind of means. I'll use that matrix I had up just a second ago. We had this thing. I had this matrix on the board a second ago. So, well, actually, maybe I don't want to use this matrix. Let's use this matrix. Sorry. I'm going to change the first row. Just to illustrate a point, I want this matrix actually. Okay. So we'll use this matrix. 1, 2, 3, 4, 5, 6. I would like to illustrate this row operation, and the way I'm going to do it is this. I'm going to change the second row by adding a certain multiple of the first row to it. Now, when I say add two rows together, all I mean is just sort of line up and add entry-wise. So these guys are lined up. I'm going to add 1 to 4. I'm going to add 2 to 5. I'm going to add 3 to 6. So you're just going to kind of line them up and go by columns. That's how you're going to add the rows. Yeah. But I have this business where I'm going to add a certain multiple. And so what I want to do is this. I want to change the second row. So change row 2, R2, by adding, let's say, -4 row 1 to it. So I'm going to add -4 times 1, or sorry, -4 times row 1 to row 2, and I'm going to change row 2. So I might notate that this way. Again, you might come up with your own way. You might just write it in words like I did. Also, some way to tell me what's happening. And it's going to end up looking like this. Okay. So I'm going to change row 2. So what I need to do is add -4 times row 1 to it. So up above is 1. I need to multiply this by -4 because I'm multiplying the first row by -4. So this gives me 1 times -4, which is -4. And then I'm going to add it to 4. -4 plus 4 is 0. So I get a 0 here in the second row. Because 4 plus 1 times -4 is 0. Okay. If I move on, I need to multiply this by -4 and add it to 5. So 5 plus 2 times -4, that's the same thing as 5 minus 8, which is -3. And check my arithmetic, make sure I'm not messing up. I don't think I'm making a mistake yet. So -3. And then we move on, and I need to add to 6. I need to go 6 plus 3 times -4. And 3 times -4 is -12. So that's 6 plus -12. That's -6. And then I'm only changing the second row, so I'm just going to keep my first row. I keep my first row. Okay. This is my new matrix where I have changed the second row just by adding a multiple by -4 of the first row to it. That's how that works. Okay. So this is definitely the most complicated row operation. Sort of harder to write down and get our hands on. But it's not, I mean, it's sort of like, let me tell you where it comes from, I guess. And so you may already have seen this, but this is pretty much coming from the elimination method that we had for solving the system of equations. So for example, if I had this system of equations, I had this system of equations, before we knew about matrices, I might have asked you to solve this with the elimination method that we had. And how did that work? Well, I needed to multiply an equation by some number so that when I added them together, a variable canceled out. And what might I wanted to cancel out? Well, maybe I want to cancel the x by getting these coefficients to be opposites. So maybe I would have multiplied this first equation by -4. So I'm going to add, what I'm going to end up doing is multiplying this equation by -4 and then adding it to this equation. That's exactly what we did down here. I took this row and multiplied it by -4. That's the same thing as taking an equation and multiplying by -4. And then I added it to the next row, which is the same thing as adding it to another equation. So this last row operation is really encoding the elimination method technique that we had before. So technically it's nothing new, but now it's encoded in this matrix language. I think the hardest thing for students usually, in my experience, is why didn't I change the first row when I did this? And that seems weird to people sometimes. And in some sense, I could just answer that by saying that's just the way we do it. And so just accept it and learn that, and we'll just move on with our lives. In some sense, that's true. And honestly, I don't know if I have a better answer than that. Other than that's just the way we do the row operation. You know, if it kind of makes you nervous, you might instead, there's like an intermediate step you might do where you might just multiply this row by -4. You might write this out. If it, you know, doing it the other way makes you nervous. You might just write out what your matrix looks like when I multiply this row by -4 and then add this down to get the new row. You might do that if that makes you more comfortable. There's nothing wrong with that. It's just, it creates extra steps is all. And in the end, you're basically going to end up undoing this multiplying by -4 anyway, later on down the road. So you might as well just package it all nicely here and not change the first row. But you'll get a better feel for that about your own preferences and whatnot as we move on. Okay. So maybe I've talked a lot. Maybe it's a good time to stop and ask, are there any questions? Throwing a lot of information at you. Okay. So it sounds like no questions at the moment. Again, if you ever have one, just let me know. Don't be shy. Okay. So what I want to do now is we have these row operations now. We have things that we're allowed to do to a matrix to turn it from one matrix into another. So now what I want to do is give you some sort of guidance. I want to give us a nice general strategy and a goal to aim for solving a system of equations using a matrix. Because right now it's like we have these operations, but like, what do I do with them? It seems like I could do all kinds of stuff, and I could end up just aimlessly changing my matrix and never accomplish anything. So I want to give us some guidance, sort of like a roadmap or an algorithm, if you will, about how to actually solve one of these. And I'm going to sort of write out in words what you do, and then it's going to be a lot more, what'll be much more enlightening is I'll give you an example. We'll work through an example on the board. So call it an algorithm for, I'm going to use this word reducing matrix. So I said that we want to turn a matrix into a simpler one. The fancy word we're going to use for simple is a reduced matrix. And I'm not going to tell you exactly what that is yet, but I think after showing you an example, I'll tell you exactly what I mean by a reduced matrix. And it'll make a little more sense. So let me tell you sort of the algorithm, the steps that you might want it to generally follow. So here's your steps. Step 1. So in your matrix, we are going to try and get a 1. We love the number 1 with our matrices. We love the numbers 1, the number 1. So we're going to try to get a 1 in the first row and first column. Of our matrix. And when I say first row, first column, that you could basically read this as the upper left corner. Upper left-hand corner. Now I want to get the number 1 in my upper left-hand corner of the matrix. So if I have like a little matrix here, I'm really talking about, let me grab another marker. I'm talking about right here, right there. I want the number 1 there. In this case, if it's already there, but if it's not, I need to get a 1 there. And the way you do that is either by swapping rows, or maybe you have to divide or multiply by a number to make this into a 1. But I want to get a 1 here. It's going to be very helpful for us. Step 2. Step 2 says the following. We're going to use that 1 to make zeros everywhere else in the first column. So I'm going to use the 1 to make zeros everywhere else in the first column. What do I mean by use the 1? I mean, I have the number 1. I can multiply anything times 1 is itself. And so the idea is that I'm going to have other numbers. Like here I have a 4 in this first column. I'd like to make this 4 into a 0 according to this step of the algorithm. So what I'm going to do is I'm going to add a multiple of the first row to this column. And since I have the number 1 there, it's easy to know which number I need. I need to cancel a 4, so I should multiply 1 by -4, so that I get 4 plus -4 is 0. So I'm going to use the 1 to cancel this by basically just multiplying this row by the opposite of this and then adding. So we're going to add multiple first row to other rows. So this is just like in the elimination method where we canceled out a variable. We're basically canceling out the x variable with this. Okay, so that's step 2. And then step 3 is basically repeat these, but in the next column. So we're basically going to move to the right once we're done and do it again in the next column. So proceed to the next column and repeat, basically. So once I've got a 1 up here and I've made zeros everywhere else in that first column, I'm going to now move to the second column. And what I'm going to do is sort of move down a row, and I'm going to make a 1. In this case, I would then want to make a 1 here. I would want a 1 where that 5 is instead. So I'd want to turn that 5 into a 1. And then once that is a 1, I would then use this 1 to make zeros everywhere else in this column. So I would start adding multiples of this row to the other rows to make like this 2 into a 0, for example, is what I would want. And that's basically it. We're going to stop before the bar, if you will. So we're going to stop when we hit this bar. Okay, so you should never, you don't need to make 1s to the right of the bar. We're going to sort of stop there. The things to the right of the bar are just kind of along for the ride. Yeah, so we don't want to make them into 1s or 0s or anything. They're just kind of along for the ride. We have to keep track of them, but that's all. Okay, so this is our algorithm. It's 3 steps technically, but we sort of repeat over and over again until we can't go any further. And this will pretty much always work for us. Yeah, so this is a